Hi class, let's take a look at problem 4. Now, problem 4 wants us to use the squeeze theorem to evaluate this limit. So here's the basic idea on the squeeze theorem, and let me actually go back to the theorem. The theorem pretty much says that you have to have a function, and your function has to be bounded by at least two other functions or values. Then if you find the actual limit of the outer ones, since you technically have an inequality, the one in the middle has to also approach the values of L. And this is going to be over some sort of an interval. Sometimes the interval may be all real numbers. So for instance, on this particular one, you're not given the bounds, but notice that if you were to observe the function of just the cosine, your cosine is bounded by technically 1 and -1. So in this case, I'm just going to say note the values of the cosine of x is less than or equal to 1 and greater than or equal to -1, and I'll just say on all real numbers. Okay, then the next portion that we're going to do is we're going to multiply by x on both ends. So times x and technically times x, and that also forces us to multiply the middle part of the function. So in this case, we're actually looking at a new inequality on -x is less than or equal to x cosine of x, and that will also be less than or equal to the values of simply x. Okay, next order of business is once we adjusted the inequality, our main goal was actually to have the function. So we were looking at having the x cosine x function, and then at this point we're going to simply evaluate the limits, and I'm just going to evaluate the limit as x approaches 0 of the bounds. So in this case x, and this is going to be, well, technically 0 for this one. And then we're going to evaluate the limit for the other end. So in this case, we're going to be evaluating it for -x. So this will be the limit as x approaches 0 of -x. And in this case, you're going to get -0 or technically 0. And at this point, we're technically done, because here's the basic idea. Since both of these values in terms of the limits, and I'm talking about these two, are approaching 0 as x approaching 0, then by the squeeze theorem, also the middle one has to go to 0. Now, you can actually observe this in terms of the limit. Here you have the values of 0, or technically as you see the origin. But in this case, the squeeze theorem will allow us to evaluate some messy limits. In this case, this was not messy, but this is pretty much it for this problem. Now, don't forget your sentence. So in this case, we basically found that -x is less than or equal to x cosine of x less than or equal to x. And in this case, it's actually on all real numbers. So I'm going to state that on the sentence. I'll just say on R. And then the limit as x approaches 0 of x is equal to 0. I'll just say comma, the limit as x approaches 0 of -x it's also equal to 0. Then by the squeeze theorem, you can conclude then the actual limit as x approaches 0 of x cosine of x has to also equal 0. And part of the theorem basically states that as long as both functions are going to a value, the one in the middle has to go to the value, provided that you're able to bound it. So as long as you're able to express it, the actual function, by being bounded by two functions, then the one in the middle has to go to the same limit. That's actually it for this one. we didn't really need to use the actual squeeze theorem because both x and cosine x are defined at 0, but it'll help us evaluate other limits that are not easy to evaluate. So that's actually it. And once again, don't forget your sentence. Your sentence has to state that, well, in this case, the inequality that was formed, and then also both of the limits. And then, well, the final portion of the actual limit for the middle one.